Hello, good morning,
Good morning.
good
Hello,
afternoon,
Alex.
everybody. Hi, Michael.
Welcome
How's it
back.
going? Thank you, thank
Welcome
you.
back.
Yeah,
Hope you had a good time in your
I had a very
extended
good time.
vacation. We had a good
Yes,
run
it
last
was.
week with Alex, with Adam, looking at the Python course in Graph Academy
Hmm.
and building the Neo4j app, and had a lot of fun going through this and showing kind of how to do the different steps
Oh,
as
cool.
building a backend in Neo4j.
I didn't watch it yet. So you
No,
went through the Python Graph Academy
course.
course?
Yeah,
Yeah.
exactly.
Oh, cool.
Yeah.
Yeah, that's a good one. Yeah.
And last week I actually got the Java course done as well. So if any of you are Java developers or no Java developers that want to build Neo4j backend apps, check out Graph Academy for the Java course as well. So we have now JavaScript, Python, Java, and Go backend development courses on Graph Academy, which is really great
That's super. I
to
posted the
see.
link in chat. So we, so yeah, I think that's super. I mean, Graph Academy is just it's growing almost every day. Felt like it. I mean, Adam
Yeah,
popping
almost
out
every
with
week. Yeah, there's
almost
there's
every week. Yeah,
There's more coming this week as well. So there's a new intermediate Cypher course coming, and then another course is also coming this week. So it's quite a development. I already spoke with Adam that we're gonna do like an at least a blog post, but perhaps even a live stream about the new courses would be nice to do, kind of to show them and
yeah,
and and, and discuss them a little bit, and also how people can walk their way through Graph Academy and so on. Perhaps that's something that you could chat with Adam
yeah.
about
I'll
as
I'll
well.
talk to Adam about this because yeah, I think it's a great repository and a great way to start learning.
Yeah,
And to explore the different ways you can use Neo4j and graphs with the various other tools that are around. So not only drivers, but everything really. And that's it's a great it's just a good start. And even
yeah.
for people that are not just beginners, but also very much for beginners. If you join, you start your journey and you go with the first sessions and you start with the fundamentals and the modeling courses, you get a perfect experience how to get going and how it
Exactly.
works.
So for
So
those of you that
super
already know
helpful.
Neo4j, perhaps it's a good thing to recommend Graph Academy to other folks, either in your team or your
Hmm.
friends or family or your grandma, if she wants to learn Neo4j and graphs. Then
Yeah, can
so
imagine
because all the
she would
courses
be.
are really short and interactive, so it's also fun and entertaining to take them as well. So
Yeah.
if you don't need the courses yourself, but then recommend them to other folks.
Yeah, and they've all been done anew. So if you have done them a couple of years ago, and you remember them, and they were great back then, of course. But now they are much more improved. You get a coding exercise inside the course training. You can directly put in your queries inside, and you get a result. And the tool tells you, okay, this is not the right answer, or this is the right answer.
Yeah,
So it's much more of an online guiding tutorial
yeah,
instead of a reading exercise. So
exactly. Yeah,
it's really good. It's really good,
yeah,
and it's fun. I,
exactly.
I, I did
Yeah.
I did the modeling and the fundamentals, and they enjoyed them a lot.
Yeah, exactly. Cool. So happy to have you
Cool.
back, Alex.
Yeah, I'm
I
I'm happy to be back. Yeah.
just arrived back. So we both had a late night.
Yep.
So you came back from your trip, and I actually I started to play Skyrim on my daughter's PS4. So I actually never played console games before, only like PC computer games, and but she got a PS4 a while ago, and got Skyrim, and then I thought, yeah, let me try that as well. So in the last 2 nights, I've
It's
been playing
yeah.
Skyrim till early
Yeah.
mornings.
I totally get it. Yeah, it's a big one, and you can be sucked in, and then you don't
Yeah,
realize, and then 5 hours later you realize, oh
yeah, when it
yeah, well,
gets light
one more
outside, right?
quest.
Especially
Yeah.
exactly, especially in summer when the birds are singing outside and
Yeah.
the sun comes
Yes.
up, then
Oops.
then you know it's time to stop. Cool, but anyway,
Cool.
so
All
we'll
right. Let's
still do the live stream today. No,
exactly.
nothing will keep
No.
us
Yeah.
from that, right? And let's
Okay.
get going.
So let's get going. Exactly. So yeah, I'll give the intro a little bit, and then we dive right in. I guess if you watch this a couple of times now, then you know what it's all about. But nevertheless. Reminder, Graph Connect is coming, so call for papers is officially closed, but yeah, now obviously ticket you can buy your tickets, you can mark your calendars. It's going down in Austin,
Oh,
Texas in
yeah, by the
early
way,
June.
we got 250 submissions for the call for papers, which was really amazing.
Yeah,
And
that's right.
I reviewed them, and the quality of the submissions has been really, really impressive. So really had a hard time to decide between talks. So if you're coming, the content will be really awesome. So there's so much
Hmm.
good content coming for Graph Connect. I wait, and um, it's really for the talks that we can't take, then that's probably also a really good source for future live streams or other webinars as such. But I'm
Yeah,
really looking
totally.
forward to Graph Connect. So it's really, really, really good content. So make sure if you can come, please come. That would be really great.
Yeah, I'm looking forward to it. I think that's going to be a great event later in the year. Um, the developer survey is still open. I hope it is. I think it is still open. So we're looking for your answers. So it's a short one, really. You can receive a special thank you gift if you do it. Just a couple of minutes, really. Quick few questions. So if you have the time, that would be great. If you can um, take the time and go through this. I'll post a link to the survey in the chat in a second. Yeah, and then hands-on or free the plan. What is it? Quick recap. What Neo4j AuraDB free is. So I'll do that in a second. If you have a data set you'd like us to explore, so we usually pick a data set, or rather Michael picks one, and we go over that. But if you have something you're interested in us exploring, if you want to know anything particularly, or have a data set you think, okay, this could be fun for this particular session here, send it over Twitter, Discord, community forums, email, whatever you want, here in chat, whatever works for you. We then look at this data set. We think what questions we could ask, what would be a good exercise to model this for the queries. We model the data set accordingly, and then we load and query this in Neo4j AuraDB free. What is Neo4j Aura? So this is just I think I didn't show this slide for quite a while, but this is the Neo4j database as a service. You have managed service with elasticity, and it will kept up to date. It manages backups. It provides continuous uptime and oversees monitoring. So everything is done for you basically. So you don't have to worry about anything. And in short, the free version or DB is limited to 50,000 nodes and 175,000 relationships, but it's free forever. So you get to keep it, and you basically have to do nothing about it. So it stays with you forever. You get access to Neo4j Bloom and browser, so you can obviously use browser for querying and loading the data, but also you get Bloom to explore your graph. So that's super handy. Yeah, I'll post a link how to get your AuraDB free instance also in a second now. But yeah, let's get going today. This week's topic is New York Times articles as a knowledge graph. So that should be cool, and yeah, we can dive in with that topic and with
Yeah,
that data set. I don't know, Michael, where did you get this data set? Maybe let's start with that.
that's a good point. So I thought, with everything happening in the world, not just this year, but also in the last, 5, 6, 7 years, uh, the importance of journalists reporting on that is really important, and kind of getting access to that data is also important, because oftentimes you don't just want to read the articles online. So we looked at this a little bit in the GDELT episode, if you remember, where we pulled in
Mhm.
this news data from this global source. Um, but especially with everything happening right now, I think it's good to be able to pull in these articles and then also enrich them with other data sets as well. And so our colleague Will actually put together this repository, which he told me about, that he used at a journalism conference, an investigative
Ah,
journalism conference, where he set up an and continuous scraper, to say so, that kind of goes to the New York Times API and pulls the most popular articles every day and puts it into a Neo4j graph. And I thought that could be a really good example for something that you can quickly get into Neo4j, and it doesn't take a lot of time, and you can do it yourself quickly.
Hmm.
So what it requires is basically just a New York Times developer account, and that was actually quite simple for me as well. So I just signed in to the developer account. I added an app in the developer account, and then I got an access key. Um,
Oh, that's very easy. Yeah.
and that's about it, right? So we only need the
Mhm.
access key, and then you go to the docs page of the APIs, which is this one here, which gives you all the different APIs. So there are a lot of them.
Mhm.
But what we look at is today the most popular API. So you can see there are lots of other ones like top stories, RSS feeds, movie reviews, books, and so on. So perhaps that's actually good content that we could dive into some other time, like the books API or the movies API,
Yeah, the
something like
movies
that.
review, exactly. Yeah, I
Yeah,
think that's a good one.
yeah, books as such, right? So,
At some point, there
um,
will be a Wordle API connection.
yeah, I guess so. I guess so. And also Archive API, where you get all
Scoring.
the metadata for a
Okay,
given
yeah, that's good.
month and
Yeah,
so on. Right. But today we will look at the most popular API.
yeah.
And that's a really simple API as such. So you basically just say you do an viewed and then number of days dot JSON, and then you provide your API key basically, right? So that's basically if you want to have 1 week, it's 7.json. If you want to have a month, then it's 30 .json, 30 days basically, right? So you just
Okay,
put in the
okay.
number of days that you want to put into the number, and then that's about it, right? And then you get results back that give you the metadata of this call,
Hmm.
right? And and if you run
Very
this
easy.
API call, then it looks like this. We look into this a little bit more detail later on as well.
Okay.
But you see that you get a status, number of results, and then for each article you get uh, title, URL, ID, source, when was it published, which section, subsection was it published in, who wrote it, title and abstract, and
Yeah.
then facets basically uh, for description, but also organizations, people. That's kind of already like entity extraction as such, right? So you basically don't have to go and do it yourself, but you can basically just let the New York Times give you their own
Yeah.
knowledge graph entity extraction, right? So you see these geo, person, and organization facets, right? And that's what you get for every article as an overview. And then if you want to get more, then there are the other APIs where you can get more metadata as well. So pretty
Hmm.
straightforward, and I thought, especially for the live stream, it's not too complex, but something that you can wrap your head around pretty quickly.
Yeah.
Right?
Yeah, that's a cool,
Um,
cool idea. Yeah.
so Will, in his repository, goes actually further. So he, after importing it into Neo4j, he has a bunch of additional information and browser guides and so on. And he also serves this whole thing as a GraphQL API. So his repository is actually more about taking this data from the New York Times, putting it into Neo4j, and then putting a GraphQL API on top of it. I don't think that we'll get to this today, but that's something that we can explore a little bit later on, as such.
I posted the link to the repository in chat, so if you
Thank
if
you.
you if you
Yeah.
wanna build upon what we did now, what we are doing now or today, then obviously
Yeah,
you can do
exactly. So, and if you look at the data model as such, it's pretty straightforward, and it represents what we've just seen in the JSON, right? So you have the
that. Hmm.
article in the center, which then has like title, URL, and publish date and things like that, and then the facets for geo, person, organization are connected as nodes. So, for instance, if you have multiple articles that share the same information about the same organization, then they would be connected via this organization, concrete organization node. The authors are extracted. Could be, of course, multiple authors as such. If there are images attached to the metadata, then these would be also in here as well, attached to the article. And then the topics, which are like the categories, if you look at these. Is the topics here on this one? I'm not sure. It doesn't. It's probably the description facets are the topics. And then if there are comments on it, so here you see one that has meta type. Jean-Baptiste won a lot of Grammys, so I always enjoyed his music, and I'm really happy that he won the Grammys. And so you see here are, for instance, some images attached. And
Yeah.
then some articles, probably not with this popular API, but with other APIs, you also get comments as well, uh, which is its own field of exploration, which then goes into like discussions and sentiment, and are there clusters of comments, and are there certain people posting same kind of comments, and do we see trolling happening, and so on. You've probably seen on many news articles there are like tens of thousands of comments of all kinds of
Yeah.
people um, that kind of need to voice their their thoughts. I've actually
Yeah.
recently listened to a podcast which was interesting, where they said uh, people commenting on things is important, but you as an author shouldn't get like too involved into the commenting section
No.
because there's a
Yeah.
lot of self-representation, and also the people commenting are only like a tiny percentage of your readership or listenership, and the majority is actually the quiet majority that just reads the article or listens to the podcast, gets the information, enjoys it or doesn't, but uh, is not, you know,
As vocal about it.
engaged or angry or whatever enough to
Yeah.
comment on it, right? And some people really comment for life, so they basically it's
Yeah.
their they really enjoy kind of putting themselves out there, and so I found this quite interesting to say, okay, actually, the number of comments is probably more like how controversial is the article, or how much like does it uh,
Yeah. And some people
does it
probably
go
just
counter against someone's ideology, and so on. But yeah,
yeah.
don't put too much weight
No,
into
no,
comments.
I definitely think that some people are out there just to put a controversial opinion there, just to strike a discussion or
Yeah,
something, just because of
exactly.
they just don't have anything else to do with their
Yeah, and
lives.
there's also oftentimes a lot of harassment in comments as well.
Yeah,
So really
yeah,
take them with a grain of salt. And I think actually, I wonder if it's easier or better to just use comments and analyze them with like an algorithm or a database or so, and don't actually read the actual content, because that might be more hurtful to you as an author, and then you get feel not great about it.
yeah, like a sentiment analysis rather than reading the actual
Yeah,
content. Yeah,
or like just a topic analysis or something like that, right? So
yeah,
that's
yeah,
exactly. So that's pretty straightforward, right? So we can query the article from the API, get the articles from the API, and then we extract these five, six elements from the article and put it into
yeah,
our ORDB as such, right? And in general, I've shown this before. If you want to create a new database in Aura, you basically just go to Neo4j Aura. I shared the link already, and then you go to databases and create database. I can show this. Can't show this today because I have too many databases already, so I can't create a new ORDB database. But what you would do, you would say create your ORDB3 database, choose a name, choose a region, and click on create. What's important is that you store the password somewhere safe. Um, and then it takes 2 to 3 minutes for your database to spin up, right? So that's basically what you can do. And then after a few minutes, your database is running, and then you have access to the information. So you can get information for the how to connect to the database. You can import dumps, as we've shown last time or a few times in the live stream. And you can also take snapshots from there. But what's important for us here is the the new buttons. So if you've used Aura before, you might have seen that this UI changed a little bit. So Bloom became Explore. Browser is now Query, and Data Importer is Import. So it's not a drop down anymore, but which hides away all the things that you can do. But this is like more for beginners. So directly, okay, what can I do with this data in my database? And if I have nothing, I import something, and otherwise I explore visually with Bloom without
perfect.
knowing Cypher, or I can query, which is then more like the people that know the query language already, as such. Right. So so I have, if you click query, it opens Neo4j browser here, and so that's an empty database. So there's nothing in there right now, and we can now look at importing the data from the API. right?
Cool. Yeah.
There's a really cool procedure. So I can say it's cool because I wrote it a long time ago. In Aura, actually, I can show you this. So if you in Aura go to the docs link up here, where it says Get Help. Yes, in the Get Started section, an APOC support page. So APOC is an Neo4j utility library that I started a long time ago, and then many other people contributed to it. So it's a very active open source project with a ton of additional utility functions and procedures and functions that you can use in Neo4j. And one thing that's especially interesting for us today is loading data. And with APOC, you can, for instance, load data from JSON API. So you basically say APOC load JSON, provide an URL, and then you get the data back from that API. So we've used this in the past in the stream, but I just thought I wanted to show as well where to find more information about all the other APOC functions as well. So that's what we're going to use. So basically, we take our URL from here, and we use APOC load JSON. So let me do this call APOC load JSON, put in the API, and then if I just hit enter, it just shows me the results here. And it's basically a large JSON object which has a number of entries. So it's called, the default return thing is called value. And now we can start to deconstruct this into the shape that we want to have. Right, so that's, you see, it looks exactly the same to the API in the browser that we had here, right? So what you get back, but these are now data structures that Cypher and Neo4j can work with as such, right?
You picked 7 days, I see.
Yeah, 7, but I could, we can also later do the 30 days as well.
Yeah, okay.
So it goes all the way up to 30 days for popular articles.
That's fine. Yeah.
So what we do is we basically get our value with yield value. And then in the value, we see that there's this results array here. And so for what we do is here, we can say unwind, which takes a list and turns it into an row, each of those. So value.results as article and return article. So that gives us not just one result, but 20 results back. So all the 20 results from the API. And you see each of the results has now the data that we have here, right? So we have the article information, but we also have the other metadata like the facets as well, right? And now we can either say we want to have things returned in individual rows. So I can say article title, I can say like article dot geofacet. Then I can also say I want to have, let's say, byline and publish date or something like that. Article.id, article.published date, and article.byline, comma. And then it had also article geo description facets. Here. Right. So if I return it like this, then I would get not an JSON structure back, but I get like rows back for the data, right? So you see here we have like the ID, the title, publish date, who wrote it, geo facets if they exist, and article facets as well, right? So and now we can basically turn the main information into an article node, like our data model showed, and then the geo facets into geo nodes and description facets into topics as such. Right? So, and I just steal, fortunately Will also put this onto his README, so I can just steal it from Will's README so that we get the same data model as well, and I don't mistype anything. So, but you see what it does. It does basically exactly the same as I had so far. Returns the article, and then we use initially merge, which is a get or create for Neo4j. So you either have the information already in the database, so it merges here on URL, which is kind of the public identifier, and so not the internal ID, but the public URL. So it's globally unique, basically. And then if the article already exists in the database, it will be just updated with the title, abstract, and the date and the authors basically, and then later on, so we can probably start with this and then run the second one. So basically, I just steal this, and instead of returning our data here, I run the merge. So it creates the article and sets these 4 informations. So if I wanted to, I can also add, for instance, a.id equals article.id, and title we already got, right? So you can also add other information here as well. Or if you import multiple sources, we could also import the source and set it as New York Times, or they even have they have also a source field here, so you can also add other things as well, right? So imagine you pull data not just from one news organization, but from 10 different ones, and you want to have the same consistent data model across all of them, because each of them has their own API, it looks different, and so on. But if you adhere to this data model, then you can kind of normalize it across all the different publishers, basically. So we can put in source here, for instance, as well, right? So if you run this, then it complains because I forgot a comma after ID. But if we run this, it fetches the data and it created 20 nodes, which were our 20 results, and said 140 properties, so that's 7 properties per node. So 1, 2, 3, 4, 5, 6, 7. And now if you look at our database, it has article nodes, and if you look at them, we can see basically for each node in the database the data that we set from the API, right? And now we could also query them for things already. So for instance, we could say, okay, what are the things that have been published on the 8th of April, for instance, right? Then we can say where n dot what's it called? Published equals date time, and then we just say 2022. I'm still not used to 2022. Where it's basically where the date is the 8th of April, right? So then we can see, okay, there were 2 articles in the and so on, right? So you can query for title contains and so on. So title contains Ukraine. Did I misspell this? Should be something, right?
Should be, yeah. Maybe not. Maybe not in the title. Well,
where's the title? Here's the title.
I don't know.
Yeah, you can look for Pusher, for instance. So here are like now try 3 records returned. So I can also search for titles or authors or whatever, right? So that's kind of just basic database functionality that we can do. We can get them back as a graph or as an visualization. And again, we can also say, okay, we actually want to return the title and dot byline and so on. So we can also use it like this. And then imagine you have an app using that, then it just gets the data like this. Okay, so that's our first part, kind of creating just the articles. But as you can see, these are lonely nodes. They have no relationships. So it's really not a good use of a graph database, right? They're all isolated. No. And I mean, you can make them chase each other on the screen, but which is fun. But it's not like a graph that we want to have. Okay, so we continue here. And if you look at the model, we would kind of extract all the related information into their own nodes and then connect it with a relationship to our article node. So the article points to these geo-information, people, topics, and so on. Right? So, and we do it for one, and then we can do the other ones similarly, right? So what it does, it takes, so each of those is actually an array in the article result. So we can iterate over the array in the article result with for each, create the other node of a certain type. So for instance, here's a topic, and with this name that's in the array, and then connect it with a relationship to the article, right? So if you add this here to to our import statement. Here it is. Then we can see that it will not create the article again because the article is already there. And it would still set the properties again of the article because, for instance, if they have been updated. But if you want to avoid this, you can also just put in on create set. So then it would only set the properties if the article had been newly created. So if I, for instance, if I run this here twice another time, then it would not do anything, right? So because it fetches the API, but it sees that the article already exists and we don't need to create, so it doesn't do anything. So that's really good for repeated imports if you don't want to add more data, but if you want to basically just, fill in the blanks as such, right? And if you add now our description topics here, then it would basically just create these additional nodes and additional relationships, but it would not change the articles themselves. So now we see it's not just articles, but articles and topics. And now finally we have some relationships. Yay, graph database. And you see now each of the articles has one or more or zero or more relationships to topics. And if I remove this limit here, it actually returns the whole graph. And we already see there is connected information here, right? So we have certain articles that share something like COVID. We have United States politics, diseases. So that's kind of one area that's almost like one cluster of information as such.
Yeah.
And then we also have the other cluster over here, which is probably the war in Ukraine over here. Right, so where you see basically the Russian invasion as a shared topic, and then each of them has other topics that they either share or have individually as such. Right, and as I said before, it's really important to see the reporting and have the reporters in Ukraine to document all the war crimes and genocide to finally get the international community to step in and do something about it. And then there are other topics here, like a college and universities topic, for instance, that's in here as well, right? And other crime-related ones as well. Okay.
That's not related to the rest of the.
Exactly, it's its own cluster, right? So you have kind of these individual clusters basically, and for instance here, the only shared link between these two is basically demonstrations and protests, basically the topic, right? So there's one article here on protests and one article here on protests in Russia, I think, right? So and so these are like actually non-related articles topic-wise, but they still share a piece or a facet of things that are in both, right? So that's kind of also interesting how you can span between multiple articles, right? So and something that we can look at then is, for instance, similarity of articles. So how similar are articles by how many shared topics do they, for instance, have, right? So it's actually a good idea before we import the other data. Perhaps that's something that we can try to do. Is if you want to list the articles and see how similar are they to each other, looking at the shared topics as such and how frequently they share topics, right? So if I do this, I just say find me all the articles that have a topic. T. We don't really care so much here which topic it is, but more that they have a topic. And then other articles that have the same topic, A2. So that's kind of our graph pattern. So that what we would also draw on a whiteboard. Basically, we have one article which has a topic, another article which also has a topic. So you can also already see like the pattern with the circular nodes here for articles, and then the pointers basically to the topic node in the middle. So that's like the power of ASCII art, that you can actually see this immediately and make sense of this, right? And then what we want to do is we want to make sure that it's not the same article, because if they share information across multiple relationships, the same article could pop up here, right? So because if it kind of goes in here and comes back On the other side, then you can come back to the same article. So we say where the articles are not the same, and then we just return the two titles and basically count how frequently they had a shared topic in common, right? So, and order this whole thing by frequency, descending limit 5, title. So by the way, browser is also helpful. So for instance, it shows you when you have a typo somewhere, for instance, this titles where it put an S too much in here. It's not a database, so it complains about this, which is quite useful.
That is
So
very
we
helpful, yeah.
return the two articles and basically count how many patterns are returned that have these two articles in common. Actually, let me do something else. What I can do is basically we can return the articles and the topics. Article.title, topic.name, article2.title, so that we just see what is returned. So you see basically one article and another article, and how frequently they are in the list together, right? So if we sort them by order by a.title, a2.title, then we see that some articles, like this one here, this pair appears twice, so they have two topics in common, right? So they don't just share one link, but they share actually two links, so they are more related, to say so, right? So because they are covering more of the same area as such, right? And actually they have even more in common, right? So it's like it goes all the way down here, so they have actually 4 things in common, right? And if you just take this first article and the second article and count how many topics were here, then we see what's the frequency of topics, right? So I basically take the same as I had here, but instead of returning the topics, I just count them as frequency, and then we return the whole list ordered by frequency descending. So the highest frequency comes first, and let's say limit 5, and this gives us the let me close this. The articles and how many topics they share, right?
How many topics they share, yeah.
Exactly. And what we also see here is basically that the pair appears twice, so we can return this or change this when we, for instance, say what you can do is IDA is less than ID2, so it's the not equality, and it's only showing up in one order basically. So it's only when the ID of article 1 is less than article 2, and then it only shows up once. So that's a quick tip on how to get this quicker. So you see that basically this appears once. These have 2 topics in common, and so you can, if you have a larger set of articles that come from, for instance, also from different sources, then you can look at how much they overlap as such. And if I wanted to return the topics as well, I could also say return collect topic.name as topics. Then I would get the list of shared topics here as well. So I can also see which ones are the topics that they share as such. Right? And this gives me already good recommendation. Imagine I'm on this article here and want to see related articles that are similar to this one, then I can use this as a recommendation query where I basically just pass in the article ID here, and then I get recommendations which articles are similar to this one, for instance. Right? So that's a quick way of getting this kind of information. Okay, that's that. And now we can basically import the other data types. So they are very similar to what we did with the topics, which is, let's steal this from Will again, the people that the article was about, the organizations, geographies. We can set photos if we have this information. So you see this looks a little bit more complicated, where we have photo metadata and then basically could connect this. And And then it also does the same for bylines. So it splits basically the byline by authors, basically, and then replaces them, connects the author by relationship. Right?
Yeah.
So there's
Because
like
this
a
is
by
yeah.
space. So that's kind of the substring that it does. Or let's do these first, and then we do a little bit more complex ones later. So one step at a time. Not getting ahead of us here. Okay, so this should add us the like other metadata about people, organizations, and geos as such.
Yeah.
So if you run this, it adds another 54 relationships. And we should see in our database now we have a geo node, a topic, a person node, and an organization node as well. And if you look at the whole database without limit here, then we see that now it's more connected, not just through topics, but the articles are also connected through geographies, for instance, countries here, or through people. So if they're or organizations as well, right? So that's something that you then see as well. So that's not so much person information as here, as you see. So here's an article with a lot of person information, which is probably Grammys, right? So like all the celebrities that are in there.
Okay, yeah, that makes sense.
And organization, kind of the Grammy Recording Academy and the location.
Okay.
And
Yeah.
here are some locations, organizations like FBI, GRU, and Justice Department, and only a few people like President Biden, Putin, and others, right? So that I think this becomes more interesting as the number of articles grows as such, right? Actually, that's something that we could do is by extending this to 30 days. Right, so I said that it's not just available for 7 days, but it's also available for 30 days. So if you pull all this data in for 30 days, then it adds 144 more relationships. And so our little database now has 230 nodes for articles and their information. And then we have 297 relationships. And if you look at them, that would give us, well, let me just execute this one here again. This gives us our whole graph here. Oh, this is only the topic graph. Let me just move this here. And this gives us like now 30 days worth of, where's my mouse? Yeah.
Yeah, if you scroll out a little bit, maybe.
Okay, there we are. So now we see that's kind of articles for 30 days. So there's a little bit more overlap between them as well.
Yeah,
Right?
more
So,
connectedness for sure. Yeah.
Exactly. And now if you want to rerun our recommendation query, basically what we had here. So we see that the same article as before is still there, but also other ones are coming up, like now super yachts and other things as well, right? So
Yeah,
so
4 seems to be like a super connected
yeah,
article.
that's almost like really exactly the same area as
Yeah.
such, right? So
Yeah.
as such. But what's interesting is, so this is only looking at topics, right? But what we can do is basically we can remove the relationship type here, or we can add multiple relationship types. So for instance, if we want to say has topic and has geo, for instance, or something like that. Right, so we can add multiple here. And so what are the articles sharing not just in one in one area, but across multiple areas basically as well. So I think it's called geography, right? About geo. Oh, sorry, about geo.
Okay.
So this would not just take the topics, but this T would be some shared information, right? So and if you run this again, now there are others, and we see also now the numbers are higher,
Okay.
and now we don't just
Yeah.
have like the topics, but also the other
geo.
pieces of information.
Yeah.
And if we remove this altogether, because we know in our graph there's currently only like article-related information connected to the article, so nothing like comments or so, right? So, but like only like geographies, organizations, people, and so on. So if you generalize this to all relationships between the articles, then we see even more other things, right? So there are also people in here and other things as well, right? So So from that perspective, um, the more, and this is called content-based recommendation, right? So which is not based on user ratings or like view counts and or user views or user interactions, but this is pure like a content-based recommendation, which you can use if you have new users on your platform. Then you would use this as cold start recommendation, right? So if the user has never interacted on
Mhm.
your platform, you still want to show them some recommendations. You use these content-based recommendations. Um, and if the user starts interacting, then you actually can use weights here, right? So for instance, if I want to say, okay, these content-based recommendations should get a weight of 2 or something like that, right? And then this is not just a frequency, but I would turn this into a score, basically, right? And then I
Ja,
would
ja,
say, okay, based on, so for instance, now it gets you score 10 if you have 5, right? Or you
ja,
do like an Jacquard similarity or something like that, where you basically add the scores and then divide by the number of mentions and so on. And what you can do is also basically starting from the current article that the user looks at, you use this content-based recommendation with scores, then you can add it, add additional like user reviews or view counts
ja.
and things like that
Mhm.
as another score. Then you could add something like how relevant is this for the viewer when the viewer is coming from a certain country? How close is this country to their country, for instance, and things
Mhm.
like that as well, right? So you can also say, okay, for an European person, some articles might be more relevant because they're happening in Europe, and other articles that are happening uh, somewhere far away that's not as current for them.
Ja,
You could kind of do things like that as well, right? So then that's, and if you're really nice to your users, you can even allow them to change their scores basically for their personal preferences, right? So they can actually say, okay, I'm I'm scoring these things in a way that uh,
ja, ja,
I
exactly.
like, right?
I'm interested in these topics, and you can say,
Exactly.
okay,
So you can also pre-select topics, right? So you could also say,
yeah,
okay, I want to have here something like nt dot a name in, and then you provide a list. Like if you have a list, like let's say, um, if you put Ukraine in here as a topic, let's say this, then you would only get articles from that personal selection or something like that, right? Or
ja,
if you have other preferences, or if you have a custom weight scoring on these kind of things, right? So basically, that's how you can build up a recommendation engine that takes multiple dimensions into account, not just the shared topics, but also other things like ratings or location or recency. You can also do something like with recency that you kind of rank articles that are older, lower, for instance, right? So you can also say basically something like this. Uh, so imagine A2 would be our recommendation, then you could do something like A2.published and you subtract this from today or from now and just get a time delta, right? And the older it is, basically you divide it by 1 or something like that, right? So and then you get basically as an age score or something like that, right? So and then you can also return the age score here. Oops. Um, okay, it's actually daytime duration between, so it's not minus but duration between, and then you can say, for instance, in days. Right, so you say what's the duration between these two, and then how many days are they old, and plus probably +1 for the. Right, so you have like an age score of stuff that's like 1 day old, 1 day old is kind of a 0, and then and so on, right? So you can basically also take these kind of things
or
into
you
account as well.
or you just sort by published ascending
Or that, yeah,
or
but you
descending.
need to
Yeah.
aggregate it, right? So because you have multiple articles, so pure sorting is not enough as such,
Ah,
right?
ja.
So you
Mm,
need to have a number that you can add to your score, basically. So it's
yes, true.
basically
Yeah,
how
for a
old are
score, yeah.
they, and then you
Yeah.
negative,
Mm.
you basically give a negative weight of too old things, for instance, right? So and then you can also add view count and other things like popularity and so on. Yeah, that would be actually have been nice if there's like a view count here, but there's no view count on this API.
No.
Okay.
But comments
If you
is
could,
another good indication of popularity. I guess if an article has many comments, then
yeah, exactly.
it would
Or
you can
yeah, it's a
assume
good
it has many
question, right?
views.
Either it's very controversial, or it's
Yeah.
very very popular. Exactly. So and the last thing that we want to add is basically the photos. So you saw that there's here this photo URL, and then also the byline. So the photos. So Will had here this photo, how to extract the photo. Um, so here's our database. This is our recommendation. So here in our loading, at the end, we can just add, it merges the photo on an media URL, but this would create basically an empty entry with not available for every article. So what you could also do is basically say, we can also filter this out where is not null. Right, so where we basically say, okay, when this is not null, then we just add the photo basically as such.
Okay, not because not every article has an image or a
Yeah,
photo
exactly. So
associated
then
with
if you
them.
run this again, then we get another 19 photo URLs. And what's actually nice in the Neo4j browser is if you have these photos, then you can also click on the URLs and you see actually the the pictures as such. Right. So and you can also in the visualization you can also click on the visualization and say I want to have the caption as representation here and not the ID or so.
Yeah.
Right. So and then these photos are then connected to articles as such. There could be also multiple photos in an article. That's what I would probably also do, not what Will has done here with the like only the zeros photo in media.
So, it's only the first one, right?
I would actually, I would actually take all of them, and then we don't even need to have this filter. We just iterate over, or we do the for each here again. Photo in article.media. This is our array here, right? So it would give us an entry here as such. And then we would just create the photos in here. So we could also have more than one basically as such. So we would do the same here. So we iterate over the media entry. So if you look at the API again, so media is here. It's an array again, right? And we can actually filter out photos if you wanted to. That's something that we can do. And then we take the media metadata as another array that we can go over as such. But these are actually just different resolutions, so it's okay to take like the first or second entry or something like that. But we want to have all the media entries here as such. So we just iterate over the media. That's kind of the second resolution, and we instead of this we just say photo. Or actually, this is actually a media, not necessarily a photo. Media. And then this is the caption. And
So in this case, we don't we don't even have to say
not available.
If it yeah.
Because we know that it already exists, right? So this is basically like this. And so we'll use here the square brackets to access the data, but if you have special characters, you can also use backticks instead, so that it works as well. So it would basically then just access the media metadata field, but because it has special characters here like dash, not just letters, you can use backticks for that. So if I have not made a mistake, then it should probably add Oh no, there are no more media. Okay. But this would add more information to each article if there was more information. Right? So we see now if you look at our articles, then several of them should also have photos as well attached to them as well. Right, these are the red ones are the photos, right? So you see that a bunch of them have photos as well. So and then you could, for instance, take the photos and send them to an image recognition API, extract additional things from the photos and attach this to the articles as well. So that's something where you can start enriching your knowledge graph even more with other information as well, right? And the other thing that we are adding is basically we're taking this string here from byline. Where's it here? Byline. There's this by and then name. Or like if there are multiple people, there's like commas or and in between here.
Yeah.
Right? Here's a comma and then an and. And so what we're doing here is basically we take this bit and turn this into author nodes as such. Right? So at the end, here we could also do this. Actually, just to show you how this would work, we can also do this after the fact, right? So we can just take our articles. And we can just do it on the articles themselves as well, right? So that's also possible after they have been imported, right? I don't need to do this during the import. I can basically do it also after the import. So what it does, it splits away the first three characters, which is this by prefix here that every byline has, and then replaces ends with comma. So we don't want to have the end here, but we just want to have a comma separated list. And then in the end, it splits the whole string on comma. So you get a list of 3 authors basically. So if I just return this here, a dot authors, a comma authors, comma a dot byline, then you see that it basically, let me just return title. So you see the title, here's our byline, and here's our list of authors basically, right? So we replace the end with comma, split the string by comma, and then we get a list of 2 or 3 or 4 people as such. Right? And then sometimes there's a space because it's comma space, and that's why there's a trim in Will's code here. There's a trim around the author which kind of removes white space before and after the text. And so if you do this, then every author basically gets an byline. Sorry, every article gets
every article gets an author. Yeah.
So we have this new relationship now, and here you see basically which. Let me remove the element here again. Which authors have been also working in which areas, right? So that's again a clustering aspect, right? Where you see certain authors, which are the orange ones, have been working in certain areas of content as well.
Yeah, kind of subject matter experts almost.
Subject matter experts or local correspondents and things like that.
Yeah, exactly.
Exactly, and so this could be yet another thing that we integrate into our recommendation. So if we go back to our recommendation query, which was here, let me take this one without the date and without the limit. So here now we get higher scores because now we also have shared authors in there as well. Right? So that's something that we can also add.
It's another relationship. Yeah.
Exactly, it's another relationship. Or I do this as a separate score. That's also something that I can do where I basically give the authors a separate score and can rank this higher or lower. And actually, I can do 1 score per type of shared content. So for geo, people, authors, topics, countries, and so on. So and then I can rank things differently depending on what I want to show my users as well.
Exactly, you can do all kinds of things, and like you said before, I mean we can give topics a certain weight as a user. You could say, okay, I follow authors because I like how they write and I like what they cover. So then this would give them
Exactly.
another plus. So you could make a very elaborate recommendation engine out of this, and then you get the articles you are most interested in
Yeah.
your front page. You could even, your customized front page would look much different than from somebody else's, because you get your own
Exactly.
filtering
Every
by
person can customize it according to their interests,
yeah.
right? Especially if they're avid news readers as such. And the
But
last
then
thing,
I
sorry.
guess that's what creates that's the bubble problem, right? I mean, if you then filter it down to your personal preferences, you don't see what's left and right anymore. And I guess I guess the New York Times doesn't want to do that
Yeah.
as such, because they kind of want to show a broad view,
Yeah.
at least in the
Yeah.
beginning.
Yeah, I
But
guess that's why you
but
show both related articles as well as popular articles. And if you
yeah.
wanted to, you could also mix in. So there's also this thing where you, in recommendations, you actually mix in articles that have a lower score, basically, or like are unrelated or don't share any of the topics, right? So that you basically always randomly
Hmm.
mix in, uh, or you have a separate list that basically also could be interesting or something like that, right? So where you
Yeah.
basically explicitly take stuff from outside of the bubble, because now, because you know what's in the bubble, you also know what's outside of the bubble, so you can
Yes, true.
explicitly add a bunch of those, or have a separate
Mm.
list that says, say, things that you would usually not see or something like that, right? And
Exactly. Yeah,
then
that's a good
that's
idea.
then interesting, right?
You can say, hey, here are the other popular articles, or the other top recommended ones that don't fit your set of requirements, but they are still interesting. So maybe be
Yeah,
something. Yeah.
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 And so the last thing that Will had in here that we've also done in the past with ICIJ data is we can look at the geos. And so if you look at the geos here again, let's do this. So you see that there are some countries in here, there are some cities in here. And so what we can do is, there are like 16 nodes right now. We
Hmm.
can do an geocoding API call, which basically sends this geo name to an geocoding API like Google or OpenStreetMap, and then gets location information back. And then we can set point information on these elements. So this runs for a little bit because we have added an throttle to not run into API limits automatically. But if you have an
No.
API key, then you can also provide your API keys, and then this can also run faster. But by default, we don't want to overload the APIs. So from that perspective, it basically adds geo information to this, and then we can, for instance, say if we have a certain geolocation, let's say if you go to Google Maps and say I want to go to Berlin or something like that, then you see latitude and longitude here in the UL, and you can just take this and return point of latitude and longitude. And I always mix this up. So this is, I think this is the right order, right?
There's a comma before the 13 at the longitude.
Oh yeah, thank you. So this is kind of our geo point, right? And from where we are here in Germany. But what we can do now is basically we take this Berlin node and then we match our geos. And then we can compute the distance basically between this geo and Berlin. There's now a new function, it's called point.distance. And we say Berlin, geo dot, what was it called? Location as distance, return g.name, distance, distance order by distance descending. Too many D's. And that's wrong here. So we can also just do a return here basically and be done. That also works. Right. And actually I want to have it ascending what's closest to Berlin, right? And
Yeah.
then So this is in meters. So that's kind of, if I divide this by 1,000, then that's kilometers basically, and around this. Right. So then I see, okay, Italy is 1,000 kilometers
Closest.
away. Ukraine is 1,300, and so on. Right? So you see basically the different things located. So some of them were not really resolved correctly, so we need to provide either split up the parentheses or remove the parentheses here, but you get the idea, right? So you can also basically use this information to say, okay, either how far is it from me or how far are these geos from each other, right? So we could also basically now create relationships between the geos that says the distance between them, and then basically say, okay, kind of how closely are they geographically related as well? So which events,
they might
which
not be
news are
related.
happening in a certain area or
Exactly,
something like that, right?
So they might not be related from a topic kind of way, but they might be close by location, and then therefore being interested.
Exactly. So you can either say what's kind of within a certain distance from a certain geo or from a certain point, or there's also point bounding box where you can provide, actually this is like a box shape bound that I want to put around this as well. And this can give you another score for your recommendation as well.
Yeah.
Cool, super. So I think we covered all the things that I wanted to cover today. And you see that even such an simple, in air quotes, data set provides a lot of detail and a lot of depth, right? So there's even more that we could do. As I said, we can analyze the pictures with an image recognition API. We can take the titles and the abstract, send it to an entity extraction API to get more information out of it, and so on, right? So there's always more that's possible here. We can pull in other information from Wikipedia or open corporates like we did 2 weeks ago to add company information, organization information, and so on. So you can really treat this as a knowledge graph and start enriching it with other data sources as well.
Yeah, maybe we do that at some point and add to it from here, where we are now, because I think that's a cool data set, and maybe we find, like you said, maybe we find another API from another publication and add to it, or Wikipedia, and then we can analyze a little bit more and then make some recommendations as a
exactly
step.
Exactly. So that's what I thought we can do another time, and I'm gonna put the queries and all the details into the repository. So if you want to try it yourself, you only need to sign up to the New York Times developer account, which took like 5 minutes or so at most, and then you can run the same example as you've done today.
So. Perfect. Sounds great. I'll add the link to the description of the YouTube video. So you obviously find that video on YouTube in a bit.
Yep.
With that, I think we're at the end of today's session. So thank you very much, Michael. This was great and very interesting, and I think this is it's always good to see that, and with the visual aspect of it all, it makes so much sense, and it's great to dive into this data.
Yeah, it's really different, right? So if you look at basically a page of a news organization like this, right? So in this shape, and if you look at it as a graph, that's a very different way of representing and consuming the data, right? And there's so much more detail hidden behind these pieces of text, right? So that it's not obvious if you just look at the articles. But how connected the whole world is kind of only shows with the graph view as such, right?
Exactly. You don't see. It starts with the author, and it's very simple as that. But you don't know. I mean, I don't know the author, so I kind of like don't even get that connection. So if somebody is the local correspondent for some region, so you while you probably know, but yeah, and then topics and then location and all of that, and then it makes it very visible that everything is connected.
Yeah, exactly. Cool. Thank you so much, Alex, and hope you can recover a little bit from your late night flight and arrival, and have a relaxed day as such. And Thank
Thank
you
you.
for being here today, everyone. I hope you liked this, and I hope this was interesting, and you can apply the same approach to other data sources, other APIs. It doesn't really matter. We just picked New York Times because it was uh, current and interesting, and also really easy to use as well.
Yeah,
And
it's super
big
easy to
thanks to
use.
Will. Big thanks to Will for preparing all the work so that we could just follow in his footsteps and use his work as such. So
Thank you, Will. Exactly. Thank you, Michael, for guiding us through, and thank you all for watching. Hope this was interesting. If it was, if you like to see a episode two where we dive into other sources and combine this, post us, put it in the comments. That would be nice to see. Other than that, we'll be back next month. No, next Monday not, because obviously it's the Easter break. So we take a week off next week. I'll be back tomorrow with a Neo4j Live with Neo Dash, with Niels de Jong. So
that's really cool. So if you can make it, please join that one. Near Dash is really cool.
that's tomorrow afternoon, 5 p.m. Central European time. But you can set a reminder on YouTube, and you get a ping when it goes live. Looking forward to that. Yeah, with that, thank you all for watching. Take care, everybody, and stay safe.
Bye bye.
Bye, Michael.